3 cosine x plus 3 equals 2 sine squared of x. Oh boy, it's different.
Can you just minus the 2 sine squared?
Let's get everything on one side. If we subtract this, we're going to have negative 2 sine squared plus 3 cosine x plus 3 equals 0. Can we factor? No. Why can we not factor? One's cosine, one's sine. If only we could get it all to be the same kind of function. Hey! Trig Identities! Sine squared is 1 minus cosine squared. So I'm going to substitute that in. That's 1 minus cosine squared. So we get everything in terms of one function, and sometimes we can use our algebra skills or arithmetic skills or techniques. That gets us 2 cosine squared plus 3 cosine x. There's negative 2 plus 3. That's going to be plus 1 equals 0. We can factor that.
Keep going.
Cosine squared. That looks very much like the first one. Just putting that out there. Very much like that one. I just changed from sines to cosines and positives to negatives, or negatives to positives. We've got 2 cosine plus 1 cosine plus 1. Now we'll split it up.
Wait, what do you do to go from the negative 2 in parentheses 1 minus cosine?
I'm going to distribute. So negative 2 times negative cosine squared gets us 2 cosine squared. Negative 2 times 1 gets us negative 2. Negative 2 plus 3 gets us positive 1. And then negative 2 and the 3 gets us positive 1. We factor, set h equal to 0. I did skip a step in here where I just set this equal to 0 and solve for cosine. Cosine x equals negative 1/2. We can do that. We've got 2 pi over 3, 4 pi over 3. Cosine is negative 1. That gets us pi. How's that look? I will. Recording this as well. I'm going to take this, I'll throw it up on Google Classroom. Everybody's here today. I know my other class, I got a bunch of people out for the music thing. So I was taking it knowing that we're not going to be there. So the video will be up there. We can watch through this. You can review it. Okay? Let's do another one. Let's jump down to the bottom left. I've got sine x plus cos x equals 1. Bottom left. So I skipped the third line, I went down to the fourth line.
Is this trigonometric thingy?
Uh-oh!
Or did I say it right
Can you square?
Whoa.
Okay.
I think I said the right thing.
We've got two different functions.
Okay.
What Megan has suggested is let's square both sides. We're allowed to. So Spencer's got it at the back. We're going to square both sides. We're going to square both sides.
So it's the Pythagorean Identities to be specific.
That's what I thought.
Oh, never mind.
Be careful with your square. You need to fully distribute. Foil! FOIL, because this is sine plus cosine times sine plus cosine.
I was talking about when I was mentioning killing myself.
This one, don't, it's not so, look how nice this turns out.
Like,
Look how nice this turns out.
this isn't fun. You feel me, right?
Do you see what I see?
Oh yeah, that equals 1.
Look, sine squared plus cosine squared, what's that? 1. Yeah, we did hear that, that's gonna be on here.
Do you ever feel like committing suicide?
No, it's not even a joke.
No, I was gonna say there's a hotline.
Look, 1 equals what? We can get rid of that. Oh, happy days. Do you see what I see?
Can you divide by 2?
But then we've got sine times cosine equals, oh, we could do that. I want to do something different though. Have we seen 2 sine cosine at all?
That's what we did with the lot or double thing.
That's our double angle formula. That whole thing. We could divide by 2, and then we've got sine equals 0, cosine equals 0. We could do that. I just wanted to show you that this is the double angle formula. Or we've got to think about sine cosine equals 0, and then we can break it apart. That's sine equals 0, cosine equals 0. Now if we go here, we've got sine of something equals 0, so that's something. Sine of what angle measures get us 0?
90,
That could be, not 90.
180,
That could be 180. What else?
360.
Could be 360. What else? Could be 0. I'm actually going to miss a little bit here. So this is saying that 2x could be 0. We could have 2x equals pi. We could have 2x equals 2 pi. Actually, 2x could equal 3 pi. But in each case, x equals 0, x equals pi over 2, x equals pi. Now, if we're careful, on the right side, if we went instead and broke it apart, divided by 2, we had sine, cosine. Sine is 0, cosine 0. What angles make sine 0? That's going to be x equals 0 or pi. Cosine equals 0. That's going to be x equals pi over 2 or 3 pi over 2. So there's actually 1, 2, 3, 4. We've got 1, 2, 3. Well, if we say that 2x equals 3 pi, then we get x is 3 pi over 2.
So wait, how would you know to do that then?
Yeah, which one would you
Yeah.
take? Show your work.
Show your work. There are 4 solutions from 0 to 2 pi.
So what if you only got the 3?
Then you're missing one.
But like, how do you know you're missing one?
You're missing one. What I will do is I will tell you how many solutions there should be.
Okay, thank you.
What I will do is I will tell you there are 4 unique solutions. I'll give you that.
Could we do another one?
You want to pick another one? 23, 24.
Can we do the other example?
The other example? Okay. So third line, we'll do the third line and then number 24 we said?
Yeah.
24, okay. So example 3, we have cosine squared plus sine equals 2. What shall we do?
So cosine squared 1 minus sine.
Let's change that cosine squared to 1 minus sine squared. Apparently.
Oh, our voices are being recorded. You gotta ask permission for that.
No, only one person needs to give permission in Connecticut.
What?
It's the law.
No, it's a definitely lies.
No. This is the legal thing because I looked it up because I knew somebody was going to be recording me for something a couple weeks ago, and I wanted to make certain my rights were accounted for. If somebody is going to be recording a conversation in Connecticut legally, only one person has to give consent. So as long as plus. No. I knew somebody was going to plan on recording a meeting that I had, and I didn't want to be recorded. So I found out that, well, I'm out of luck.
So it can be the person who is recording it. Wow. That's not right. That's not right.
You can clearly see that it's being recorded, so I haven't messed with any of your rights. Plus, you're also in school, so you have no rights. Sorry, no, I've been there. As a teacher, I have very few rights as well. I lost my cord. Somebody stole my cord off my desk, so I'm kind of in trouble right now. All right. This hopefully doesn't look too bad. Get everything on one side.
Steal one from a student who has no rights.
I'm pretty certain you have more rights than I do a few times.
My dog got a haircut. He's really fluffy. I'm so happy you have no idea. Seriously, you really don't. I can't wait till this
Added sign to the right. Subtract. Added sign squared to the right. Subtracted sign to the right. Subtracted 1. That should be plus 1. Thank you.
But you shouldn't sign x squared b.
Nope. I took this and I added it to the right side.
Oh, okay.
Took this. I like having my leading coefficient positive, so I just put everything up.
Isn't it 1 minus 2?
It's going to be 2 minus 1.
So I thought you were moving the 2 to that.
I'm going to move everything to the right. Moved everything to the right. So change it how you want. Verify that this is the same thing. Can we factor that?
So why did sine x go from positive to negative?
I subtracted it to the right. So I took this and I moved it over to this side.
But the 0
I'm going to move everything to the right side. So I'm going to add sine squared. So I'm going to have sine squared of x. I'm going to subtract sine of x. I'm going to subtract 1. But because I'm picky, I like writing my equation on the left side because that's the way I like doing things. It's exactly the same thing.
It's not factored.
2 minus 1. Watch the video. Can we factor? No. So what do we do? All right. So we've got sine of x. Negative b is negative 1. Plus or minus the square root. B squared 1 minus 4ac. Minus, so that's 1 minus 4 times 1 times 1. That's negative 3 all over 2a.
Now we're working within the metric.
Where does this show up on a unit circle?
Oh, let me
Where are their eyes on a unit circle? All right, we're done. No solution. Unless I made a mistake somewhere, which is a possibility. But otherwise, there's no solution.
Will there be a lot of questions on the test that'll be no solution?
No.
Okay.
I'm going to tell you how many solutions there are. So if I tell you there are 0 solutions, you know that there's no solution. I'll-
Wait, so then we have to do the problem?
Yeah.
Well, that's why I wouldn't put that on there.
Okay.
All right, what do we say? 24?
Before we start, just like a disclaimer to anyone that's listening and worried about my mental health, I'm fine.
All right.
I do not want to kill myself.
Good
I
to
don't
know.
want to have an unnecessary meeting with the counselor. So
All right.
there you go. All right.
Good. Sine of x plus cosine x equals negative root 2. What should we do?
It's like the last one.
You want to square it again?
Let's square both sides. We square both sides. We've got sine squared plus 2 sine x cosine x plus cosine squared equals 2. Sine squared plus cosine squared is 1. Subtract the 1. Now here, we have to use the double angle formula. Doesn't work if we divide by 2. Have to use the double angle formula. Does not work if we divide by 2. I'm going to do this both ways to show why one doesn't work. So here on the left, this 2 sine times cosine, we saw that is sine of 2x equals 1. And so sine of something equals 1. Well, that something has to be, you tell me, pi over 2. So we know that 2x is pi over 2. And so then x equals pi over 4.
Is that the right way? Yeah.
Or, if we divide by 2, we've got sine of x times cosine of x equals 1/2. How do we proceed from this point? We need two numbers that multiply to 1/2. How many different numbers are there that multiply to 1/2? A lot. All right, quite a few of them. When we split them up, it only works if we split them up if we're equal to 0. Because something multiplied by 0, one of them's got to be 0. That's called the zero product property.
Wait, where do you get the pi from when you do 2x equals pi over 2?
So we're thinking, I'm going to block this out for a minute, sine of something equals 1.
Yeah.
Sine of something equals 1. So sine of what angle gets us 1? We go to the unit circle, that's straight up, that's pi over 2. Pi over 2, so we get 2x equals pi over 2. So it's sine of something. Now whatever that something is, that something just happens to be 2x this time. Now pi over 4. Let's check this. Let's check this. What's sine of pi over 4?
Oh, wait,
Root 2 over 2. What's cosine of pi over 4? Root 2 over 2. Root 2 over 2 plus root 2 over 2 is 2 root 2 over 2, which is just root 2. It's not negative. Uh-oh. This negative canceled out when we squared everything. Well, we need these pi over 2, root 2 over 2s that get us to negative. If we look at sine of 2x, what's the period of that function? Sine of 2x, what's the period? It's going to be 2 pi over b. 2 pi over 2 is going to be pi. If we take pi over 4 and we add pi, what do we get? We get 5 pi over 4. We added the period. Now if we check that 5 pi over 4, what's the sine of 5 pi over 4? That's negative root 2 over 2. Cosine of 5 pi over 4. Negative root 2 over 2. Negative root 2 over 2 plus negative root 2 over 2 is negative root 2. So this is what we actually have. We added the period there. What would help is you can always just take the original and you can graph it. If you pop this into the calculator, you're going to see some wave, and you can easily find a solution that way. So let's go in. I need my calculus for later. Sine of x plus cosine of x. Make certain we are in radian mode. I'm going to go from 0 to yes. If there's a pi, use radians. If there's a little 0 glyph, the degree bubble, use degrees. It's going to go pretty much in order. So it'll be. I'll put it in a reminder. Let's go 0. Only seniors and if you have an A average.
How does adding a period change it?
So here is the graph of sine x plus cosine x. I will graph also negative root 2. And we will look, where do those two intersect? When we squared everything, it kind of got rid of this extra... we changed from 2 functions to 1 function, sine and cosine just to 1. It ignored a bit of this change here. We want to find where do those 2 graphs intersect. If we look at the graph, shh, give me a minute. If we look at that, how many times does the blue and the red graph touch? Once. We could find that, and we find that it is 5 pi over 4. So you can also put this in the calculator to visualize how many solutions you should have and what makes sense.
So then is that the only solution?
That is the only solution that we'll be looking for.
Wait, so like, would the period depend on like